So friends, in our MU class 4 orals, there are some questions are on the topic called welding. So these are as follows: visual checks and care while welding, types of welding defects, what is non-destructive test, types of non-destructive test. So in this video, I will cover all these questions. And friends, I have made one part one video for the welding questions, and that video covers all these questions which I have provided in the list. So you can go through that video. I will provide you the link, or you can directly go to my channel Marine Helpboard and follow the welding part 1. So now moving towards our part 2 video, visual checks and care while welding. So this is the important thing. We should visually check and take care while welding about the current setting, length of arc, angle of electrode, speed of travel, selection of electrode. So if all these points are not taken care, then they may lead to welding defects. And if there are welding defects, it may decrease the lifetime of the workpiece, or we will lose the strength of the workpiece. So we should keep in mind all these points. Now moving towards our types of welding defects. So the welding defects are because if we are not taking care of the points which I have told you in my previous slide, so they may lead to some welding defect. So these are the types of welding defects. So they are as follows: slag inclusion, undercut, porosity, incomplete fusion, cracks, overlap, underfill, spatter, incomplete penetration, excessive penetration, misalignment. This is very important question asked in our MD orals in different ways. Like tell me about types of welding defects, or tell me about 5 or 8 welding defects, or they will ask you that explain briefly about slag inclusion or undercut or underfill or any one of them, misalignment, any one of them they will ask. So please keep watching till the end. I will explain you all of them one by one. So now moving towards slag inclusion. So slag is the waste material created, and bits of this solid material can become incorporated into well. Bits of flux and rust can be counted as slag. This is caused by low amperage, improper techniques, and slow travel rate. So, friends, you would have seen when we weld, after welding, we keep on cleaning the slag with the help of wire brush. So, that is caused due to these factors, and we should keep on cleaning after layer by layer if we weld, because if this slag inclusion is there, it will decrease the lifetime of the workpiece and also decrease the strength of the welding joint. So basically slag inclusion is seen when we are not cleaning our welding joint and we keep on welding layer by layer, and if this slag remains inside, so this will lead to the defect called slag inclusion, and it can be prevented by increasing amperage, increasing travel rate, and can be repaired with the help of grinding process. Now moving towards our second defect, undercut. Undercutting is an extremely common welding defect. It happens when your base metal is burned away at one of the toes of a weld. So as in figure you can see that a portion of a base metal melted away. So this comes under undercut defect. So it is caused due to the high amperage, wrong electrode angle, long arc length, electrode is too large for the base metal. So whatever I am telling you, I have taken from a manual of a training institute. So now moving towards our third defect. So in this defect, air bubbles or gases are present in the weld zone. So as in figure, you can see that there are some bubbles inside the welding joint, and it may lead to the defect. So this is caused by the inclusion of atmospheric gases, sulfur in weld metal, or surface contamination, and can be prevented by slower speed to allow time to gases to escape. So this is what about the porosity. Now moving towards our fourth defect, incomplete fusion. A weld in which fusion has not occurred throughout entire cross section of joint. So as in figure you can see that some of the place are been left to where fusion has been not done. So this comes under the defect incomplete fusion, because of which joints are not strong or not having proper strength. So it may caused because of low amperage, fast travel speed, short arc cap, lack of preheat, electrode too small, unclean base metal. So cleaning is very important while welding. It may lead, if we are not cleaning, it may lead to many defects. Like slag inclusion is also due to not cleaning the welding joints, and this incomplete fusion is also when we are not cleaning the joint properly. So friends, in this video I will cover the key points which will make you understand all the defects because if I will go slow, this video will be very long. So that's why I will go little bit fast. So now moving towards our fourth defect, cracks. So it is a discontinuity in the metal that significantly reduces strength. Weld cracking refers to a depression left at the termination of a weld where the weld pool is left unfilled. Most forms of weld cracking result from the shrinkage strains that occur as the weld metal cools and are caused by low ductile weld. So these are caused by whenever there is shrinkage seen at the time of cooling and also seen in the low ductile weld. So for the prevention, preheating the base material prior to welding can also prevent and cold cracking by slowing down the cooling rate. So wherever we think that there will be cold cracking, so we can slow down the cooling rate and helping in maintaining the ductility of the weld and the base material. So basically the cracks happen whenever the cooling rate is not proper and we are having low ductile weld. So you can see in the images given below, this type of defect is known as crack. So now moving towards our next defect, overlap. Weld metal spills beyond joint onto part surface but no fusion occurs. As in the figure, it is clear that you can see that overlap is when the weld metal is coming above the base metal in excessive quantity, and it is caused because of the improper welding technique. Steep electrode angle means the angle is very less. Fast travel speed. Now moving towards our next defect, spatter. So in this defect, small particles of metal that attach themselves to the surface of the material. This is due to the high arc power damp electrode. So in the image, it is clear that some small particles get stick to the surface of the base metal. So this defect is known as spatter. So friends, hope you would have understood all the defects till now. Now moving towards our next defect. So in this type of defect, from image only it is clear that the filler metal is not properly filled. Depression in weld below adjacent base metal surface is seen. So for repairing it, we can fill it with the filler metal, and hope this is clear. So now moving towards our next defect, incomplete penetration. So this happens when your filler metal and the base metal are not joined properly, and the result, a gap or a crack is seen in the welding joint. So as from the image it is clear that there is gap. In my image 1 the gap is above, and in image 2 the gap is at the bottom. So this is known as incomplete penetration. So this is caused due to low amperage, low preheat, tight root opening, fast travel speed, short arc length. And the prevention is that we should follow the correct contributing factors at the time of welding. So now moving towards our next defect, excessive penetration. So from the image only it is clear that whenever we are welding the filler metal above the base metal or below the base metal, so it comes under the defect known as excessive penetration. Now moving next, misalignment defect. So from the image only it is clear that whenever we are not aligning the workpiece, so it will lead to the misalignment. So it can be linear or angular. So hope you would have understood about all the defects of the welding. So these all are the defects of welding, but how will we know that which defect is there on our workpiece? So for that there are some non-destructive tests. So without wasting our time, we will move towards what is non-destructive test. So friend, this is most important topic which is asked in our MMT orals. So please watch the video till the end. So basically non-destructive testing is the testing in which we are not causing any damage to the original part, and in other words we are not impairing its future usefulness. So this is the best technique which we can use at the time of testing or inspection of the workpiece, because in this we are not damaging the workpiece and we are not decreasing the strength of the workpiece by testing on it. So this is what non-destructive testing is. So now moving towards the types of non-destructive testing. So this question is asked in many ways, like tell me about the types of non-destructive test, or tell me the names of 8 non-destructive tests, or they will ask you first names of the non-destructive test and they will ask you to define any one of them or any two of them, or they will ask specifically like explain dye penetration test. So mostly they ask about dye penetration test or magnetic particle testing. So I will explain you briefly about all one by one. So now moving towards our visual inspection. So in this visual inspection, whatever we can see, visualize with our eyes that comes under visual inspection. So after welding like undercut, lack of fluid fusion, any pinholes for gas or slag, amount of spatter, dimension of weld or misalignment, or any dirty particle on the workpiece. So whatever we are easily able to see with our eyes comes under visual inspection. So now moving towards our second test, dye penetration test. So it is also called as a liquid penetration test or penetrant testing, and it is widely applied and low cost inspection method used to locate surface breaking defects in all non-porous materials. So this method is used widely because it is low cost and we can easily make out the cracks on the surface. So there are various steps in which this test is carried out. So the first step is pre-cleaning step. So in this we are using a cleaner spray to clean and remove the dirt from the surface and making it free of contamination. Now in second step we are using penetrant spray. So this spray is applied to the surface of the item being tested, and it is allowed to soak into any flaws. Generally around 5 to 30 minutes we are keeping the workpiece so that penetrant is easily soaked by the surface. So the third step is removing the penetrant. So in this we will remove the excessive penetrant from the surface which is being tested. And now moving towards our fourth step. So now fourth step is the developer spray. So this spray is sprayed on the surface which will make you visible all the defect. It will give the indication of all the defect on the surface. So this is what how we carry out our dye penetration test. So the basic summary of this test is that first we are having a cleaner spray, second we are having penetrant spray, third is our developer spray. So this is how we carry out our dye penetration test or DP test. So if you have not got the test how we are doing, so I have attached you one digi learning video which will make you visualize about how we perform that test.
This method is used to detect flaws that are open to surface, such as cracks, porosity, and cold shells. Dye penetrant test can be effectively used in inspection of ferrous and especially non-ferrous metals such as plastics, glass, and ceramics. This is also used to test the weld works. The specimen, which is to be inspected, is chemically cleaned first to remove the dirt and other foreign particles. Next, the penetrant, which is a very fine thin oil, usually dyed bright red or ultraviolet fluorescent, is applied and allowed to remain in contact with the surface for 10 minutes. During this period, capillary action draws the penetrant into the crack. The surplus penetrant on the surface is removed completely and thin coating of powder chalk is applied. After certain minutes, the chalk draws the dye out of the crack to form visible indication of flaws, commonly known as bleed out. Inspector carries out his inspection after 3 to 5 minutes of development time using ultraviolet radiation. Major advantages: it is applicable for testing both ferrous and non-ferrous metal. Disadvantages: it is restricted to surface breaking cracks only.
So friends, hope you have got how we do dye penetration test. So now moving towards our second test, magnet particle testing. In this type of test, the part is magnetized. Finally, mild iron particles coated with a dye pigment are then applied to the specimen. These particles are attracted to magnetic flux leakage fields and will cluster to form an indication directly over the discontinuity. This indication can be visually detected under proper lighting conditions. So basically in this type of test, first we magnetize the workpiece. Then after magnetizing, we put some iron particles on this workpiece. So now once we have put these iron particles on the workpiece, so due to the magnetic flux leakage fields, this will cluster in a form which are easily visible by our eyes. So the pattern is as you are seeing in the image. So from image only it is clear that the magnetic field lines change its pattern when they are coming in the contact to the crack. So it is the clear indication that we will get visually. So for this magnetic particle testing, I have attached one DG e-learning video which will clear all the concept for this test. So the video is as follows.
This method is used to detect surface and subsurface discontinuities in ferromagnetic substances. This is also used to test the weld works. The component which is to be tested is cleaned first. After cleaning, the specimen can be magnetized, either by direct magnetization or by indirect magnetization. Direct magnetization occurs when electric current is passed directly through a specimen to produce a magnetic field. In indirect magnetization, magnetic field is applied by using a strong external magnetic field without passing current through the specimen. Indirect magnetization can be done by using permanent magnets or electromagnets. Since magnetic fields in permanent magnet cannot be varied, electromagnets are preferred usually for testing. Electromagnet consists of coil of wires through which current is supplied to produce magnetic field. The amount of magnetic field produced depends on amount of current passed through the coil. Magnetic flux is created is used to detect the flaws in the specimen. This flux lines running along the surface will deviate from the path if it approaches a crack. Fine magnetic particles are applied to the surface of specimen for visible indication of cracks. These fine magnetic particles are attracted to the area of flux deviation, creating a visible indication of flaw. Simplicity of operation is the main advantage of magnetic particle testing. Major disadvantage of this method is that it is restricted to ferromagnetic substance, surface, or near surface flaws.
Hope you would have understood about this magnetic particle testing. So now moving towards our third test, radiography test. So here we use higher energy version of a electromagnetic waves with a short wavelength. So the radiation can come from the X-ray generator or a radioactive source. So for this radiography testing, also I have attached one DG learning video which will make you understand about the concept of this test.
Radiography technique is used to determine internal flaws in ferrous, non-ferrous metals, and other materials. This is also used to test the weld works. Here, the components are exposed to short wavelength radiations in the form of X-rays, where wavelength is less than 0.001 into 10 to the power of -8 centimeters to about 40 into 10 to the power of -8 centimeters. Gamma rays, whose wavelength is about 0.005 into 10 to the power of -8 centimeters to 3 into 10 to the power of -8 centimeters, from a suitable source, such as an X-ray tube or cobalt-60, can also be used instead of X-rays. Gamma rays, which are produced by radioisotopes such as cobalt-60, can penetrate through specimen and can inspect better thickness than X-rays. Specimen is tested by placing between the source of radiation and film. The film is used as a recording medium in radiography testing. Both sides of the film base are covered by protective coating and emulsion coating. The base is made of polyesters and provide transparent medium. The emulsion is a suspension of silver salts in gelatin. The emulsion coating increases quantity of radiation absorbed. Protective coating is done to safeguard the film externally. Large radiations are passed in defecting areas, and the film appears to be darker. The main advantage of radiography test is that it is very much suitable for identifying flaws in thin section, and it is suitable for any type of material. Disadvantage of radiography test is that it is not suitable for detecting defects in thick sections and also in the surface of specimen. And another disadvantage is that it cannot indicate the depth of defect below the surface. Major disadvantage of radiography test is it causes health hazards.
So friends, hope you would have understood this radiography testing. Now moving towards our fourth test, eddy current test. So here are three figures A, B and C. So in figure A, the alternating current flowing through the coil at a chosen frequency generates a magnetic field around the coil. So in figure A, AC current is flowing which will generate a magnetic field around the coil. So in B figure, when the coil is placed close to an electrically conductive material, eddy current is included in the material. So whenever we are bringing this coil near the material, so this will flow the eddy current in the material also. So the third figure says if a flaw in the conductive material disturbs the eddy current circulation, the magnetic coupling with the probe is changed and the defect signal can be read by measuring the coil impedance variation. So the summary of the test is that we are having a coil in which at a chosen frequency we will pass a alternating current, due to which some magnetic field will be generated. So once the magnetic field is generated, we will bring that to the workpiece. So when we will bring it to the workpiece, the eddy current will also be generated in that workpiece. So when there is any defect, so it will send a defect signal which can be measured by the coil impedance variation. So this is how we will know that there is a defect in the workpiece. So this is how we are carrying our eddy current test. So you can see there is one probe by which we are testing the workpiece or any part which we are welding. So now moving towards our next test, ultrasonic inspection or testing. So there are two types of ultrasonic inspection, pulse echo and imaging. So in our field only pulse echo is used. So in this high frequency sound waves are introduced into a material and they are reflected back from surface or flaws. Reflected sound energy is displayed versus time, and inspector can visualize a cross section of a specimen showing the depth of features that reflect sound. So friends, from figure only it is clear that we are sending a high frequency sound wave through a material and we are getting the echo back very early for the crack, and for the surface where it is okay the echo is returning late. So the detector will detect and we will get this indication in the screen. So friends, for this also I have attached one DG e-learning video from which you will get a better idea about this test.
Ultrasonic testing is used to determine internal flaws by passing high-frequency sound pulses through the specimen. Thickness and length up to 30 feet can be tested. This is also used to test the weld works. An ultrasonic system consists of pulsar, transducer, and display devices. The function of pulsar is to produce high voltage electric pulses, and they are used to drive the transducer. The transducer in turn generates high frequency ultrasonic energy. The sound energy produced by transducer is directed on the specimen, which is to be inspected for defects. The sound wave gets reflected from its path if it approaches crack in the specimen. Thus, the reflected wave signal is converted into electrical signal by transducer, and it is displayed on the screen. The intensity of reflection and distortions represent the position, size, and type of defects in the specimen. The main advantage is that it is portable and can be automated fully. Disadvantage of ultrasonic testing is that cast iron and other coarse-grained materials are difficult to inspect due to low sound transmission and high signal noise. Thus,
So hope you would have understood about this ultrasonic testing. So now moving towards our next test, infrared testing. So infrared testing is a technique that uses thermography and infrared imaging and measurement camera to see and measure infrared energy emitted from an object. So in this test, basically we are using infrared rays which are tested with the help of an measurement camera. So this test can be used to heat development, lack of insulation, thin walls in construction and all. Now moving next, leak testing. So this technique is used to detect and locate leaks in pressure contaminant parts, pressure vessels and structures. Leaks can be detected by using liquid and gas penetration techniques, electronic listening devices, pressure gauge measurement or soap bubble test. So friends, you are aware about this test. This leak testing is for the fresh water which we are doing in fresh water or cylinder head we are doing, or for boiler we are using, or for our refrigerant leak test we are using soap bubble. So these all tests come under leak testing. So now moving towards our next test, acoustic emission testing. So it takes advantage of the sharp sound that PCCP emits when it breaks or slips to identify areas of active distress within a construction. It can be used to verify the structural integrity of pressure vessels, spares, high temperature reactors and piping, storage tanks, and more. The inspection is executed externally and shutdown of the process may often not be necessary. So, from the diagram, you can understand that the acoustic emission test is done on the pressure vessel. So there are acoustic emission sensors and detectors. So when a pressure is applied to this pressure vessel, so there will be a sharp sound wave which will be detected by these sensors and the detectors, and which can be measured easily, and you will know that there is some crack. So this is how we are doing acoustic emission testing. So another testing is acoustic resonance testing. So after an impact, a specimen will vibrate in certain characteristic modes and frequencies that can be measured by a microphone or laser vibrometer. Typical detecting faults are cracked cavities, detached layers, hardness deviation in material. So in this test, in our acoustic emission testing, we are measuring the sound wave. So in this, we will measure the vibration of the specimen. So this is how we are doing these both tests. In our MD oral, mostly the surveyor asks about dye penetration test, and sometimes they ask about magnetic particle testing. So for rest, they are asking only names, like tell about 8 non-destructive test names. So you have to only tell them name, and when they are asking about explain dye penetration test, so you can explain now easily. So this video is the welding questions part 2, in which I have covered welding defect and non-destructive test, and there is welding questions part 1, in which I have covered all these questions. So these questions are also important, so go through that video also. I have uploaded on Marine Help Board, and later I will provide you the link also. So friends, if this video was helpful, please like and share the video and subscribe the channel Marine Help Board